The classic pendulum bob question. And this is a really cool one because it can also be combined with things like momentum. The pendulum is shot with a bullet, causing the pendulum to swing upwards. Let's just look at what's happening with the pendulum though. So it says a 5.2 kilogram pendulum bob is suspended from a ceiling by a 1.7 meter long string. So here is my picture. So that string is 1.7 meters. The pendulum is pulled to one side such that the string makes a 33 angle from the vertical. So that's 33 degrees. One thing many people forget is that it's still the same string. So this line is also 1.7 meters. The question is, what is the speed at the bottom? So we're trying to find out how fast is it going to be right here. We know at this point, if we just pull and release, our v at this point is 0 meters per second. So the question is, what is the velocity when it gets to the bottom right there? So this question we have to do a little bit of geometry in order to solve, because we need to know how far it actually falls. So what we are interested in is, what is this height? Because even though the distance is this circular arc, we're interested in just that potential energy is being converted into kinetic energy. So what we can actually do is do a little bit of trigonometry to solve for L first, using our triangle, where we have this triangle 33 degrees and 1.7 meters. So this right there, L, is equal to 1.7 cosine 33 degrees. And therefore we can see h is just equal to, the total length is 1.7 meters, but if we subtract that 1.7 meters cosine 33 degrees, we get how far the object's going to fall. And we get a value of height is equal to 0.274 meters. So it's actually not that high. So you know that energy at 1 must equal to energy at 2. Initially it just has potential energy. Later on it's going to have just kinetic energy. If we use that as our 0 reference line, that lowest point as our reference line, makes our life a bit easier. We simplify to that square root is equal to 2g8, gh once again. So plug in our values. So we have 0.274 multiplied by gravity multiplied by 2, and we square root our value. We end up with a speed of 2.3 meters per second.